Hello, today we are discussing the Claisen ester condensation or Claisen acylation. In this tutorial we cover general reaction mechanism, examples, application in natural and total synthesis, and selectivity or in a biological systems. So this is general reaction of the Claisen ester condensation. See, this is a ester condensations. Two identical or two different ester can be combined here. So here the two molecule of this ester combined with the beta keto ester is giving the products. So the different ester can be combined like this aromatic esters combined with this aliphatic esters, also giving the keto esters product. So this is not a limited to the ester-ester condensation with ketone and ester can combines, giving the also skillful reactions and further give the synthetic utility of these reactions. So other reactions, other reagents are also possible. The reagents are used in Claisen ester condensation is the sodium hydride, sodium ethoxide, but most probably use the sodium ethoxide base in normal reactions, normal conditions. This is the most popular reagent you can say in ester condensation, sodium ethoxide. You can LDA and PS3CO Na can also used. The acylation term can also use in the synthetics utilities. So this is a diethyl, you can say carbonate can combine with the ester which give the here the ester groups. You can introduce the ester, not hydrolysis. Here ester group may be present, not hydrolyzed to the acids. Let's see how the synthetic utilities are given in these reactions. So this is summary of different condition when you combine having the ester with combination of the other esters, simply beta keto esters. Second is the combination of diethyl oxalate combined with give the esters, also having the two ester moieties. So this is special kind of some condition where you use the diester with the esters combination. Ethyl formate is the most important introduction to the aldehyde or keto group here, and new to the beta position to the ester groups. This is important number of reaction, number of synthetics, now natural product synthesis, aldehyde introductions by the sodium ethoxide. You can use the base or sodium hydride. Ethyl formate is the reagent for introduction to the aldehyde groups. So next is the diethyl carbonate introduction to the ester moiety to the this old esters. You can say new introducing the ester moieties, COH. So let's focus on the mechanism part, how the ester condensations works, how the why important, what is the mechanistic possibility of the ester, what are requirement for the Claisen ester condensations. Firstly, the 2 alpha hydrogen is required to complete the process. Why? We will discuss it. Why this is 2 alpha hydrogen is required. One molecule base is consumed. See how this are generally not confused with the Claisen rearrangement. That's very different reactions. Not confused with this condensation reaction. So please avoid the Claisen rearrangement is the difference. So let's see the mechanism. First of the sodium base ethoxide attack on the hydrogen alpha hydrogen, then it produce the enolate. As you see the aldehyde reactions and low condensation reactions or any condensation type is generation of the enolates. It is stabilized by the resonance. So now we see the ethanol is produced, so consumptions. Now the attack of this enolate into the ester groups, addition of enolate to the esters give the products like tetrahedral intermediate like products. So it generally lone pair is taken here and ethoxide is come out knockout here. So this is a product in this further reaction. This when you oxygen lone pair negative charge ion here, it come out knockout here, ethoxide ion come out knockout, you can say this is a product. Okay, now this is product. What is the second ethoxide ion required? Why this second alpha hydrogen is required? Because when you this product is obtained, this is a further possibility to attack the sodium ethoxide ion or ethoxide ion, give the to this reactant. Further, this can be not fully fledged products informations or formations. It can go to back. It can go to back. So second hydrogen is the for the protection for the product. So when this is uh, hydrogen is abstracted, because this is a acidic hydrogen, both are the acidic hydrogen, because this is the acidic group, this is carbonyl, so it is the acidic hydrogen. So this is taken by this negative charge and acidic workup. Note down here, acidic workup give the product. If this is not here present, not a alpha hydrogen is not present, so simply you can say the generally reaction is not possible. So two alpha hydrogen is required. One is abstracted already here, second is here the abstracted here. If this is not abstracted, the product break down into the substrate, go to the reaction left side, not a product side, go to reaction reactant sides. So this hydrogen abstraction is necessary. This is a acidic hydrogen, so this is a as important step for the product formations. If this is not present, the reaction go to the reactant side. So this second hydrogen abstraction play important role formation of the products. You can search the text box more explanations why this is a what is the pK value of this hydrogen between the ester and carbonyl is I think acidic hydrogen. If this is not available, the reaction can go to the reactant side. So this is a one ethanol is ejected here, this ethoxide and knockout here used here. So one ethanol is consumed, the base is not a catalyst, base is consumed here. Simply base is not catalysis acting as here, the base is consumed, lot of base is consumed, one equivalent base is consumed in these reactions. So this hydrogen is generally acidic, so it can be taken by ethoxide ion. So these are the example: diethoxylate, diethyloxylate are taking here the introduction to this type of the keto esters. For the loss of carbon monoxide introduced the ester groups. Ethyl formate already discussed, introduction of the aldehyde group here near to the carbonyl, important reaction synthesis of some natural products. Here is also similar case, introduction to the nearby the aldehyde group like ketone or ester. Hydrogen formate is introduction to the aldehyde groups. The ester and ketone give the diketone, important reaction synthesis of diketone synthesis, further undergo to synthesis of intermediate of nicotine. So the selectivity or little bit or sodium ethoxide form. This is the general the ester condensation can be combined with the presence of the titanium tetrachloride and the tetrathilamine. So the this if we take this type of the molecule, the ester molecules crossed, sometime the crossed is the major product, not self condensation. It goes to self condensation, but use of the titanium salts or titanium compounds tephalates can be used for enhance the crossed selectivity. So this is a general reaction of the crossing reaction, not self condensation using the titanium. A cross product is major product. Electronic acid synthesizing by using this titanium compounds. Ester or ester can be coupled. Other metal can also used like zirconium or the tolerance of this type of the reagents is the halogen tolerance ketone group. You can use here the ketone tosylate group to complete the reaction. It can be tolerate, but sodium ethoxide little bit more difficult tolerate groups. So these are the selectivity. You can use the titanium metal, the zirconium metal in ester, Claisen ester condensations. Oh, this is the applications. This is a ketone, introduction to the diketone. Already discussed when ketone or ester combined will give the diketone and it will be ketoenol tetramerize, and combination of cyclization give the trypsin. This natural alkyl flavors. Number of fruits can present trypsins, or this is ethyl format, introduction of aldehydes near to the keto group, like here the aldehyde is adding. So here the aldehyde is the adding the nearby hood of the ketones and undergo the isoflavins. This is also used in natural product synthesis, or natural product synthesis are already discussed. So this is also sodium introduction to aldehyde groups and acrones, equilines, carolines, and number of natural product synthesis using this, and introduction to the ester groups, dicarbonates, also introduction the COAT groups. I already discussed here how this reaction is introducing the COOT groups. So here also introduction is COOT group, ethyl groups is caroline synthesis forwards. So the biological system ester condensation not look like any producing strong base ethoxide. So biological system lose of carbon dioxide produce the inner load and combined with the esters. So here the carbon dioxide lose produce the inner load can into the this uh, esters, thioesters, generally not simple oxygen. This is thioesters. You can watch my detailed videos on this type of reactions in biosynthesis reaction. Please watch that tutorial, biosynthesis of natural product, in fully detailed how Claisen ester condensation synthesis of terpenes and natural products. So here the carbon dioxide is loose and produce the inner load and attack here, produce the ketoesters, and for the number of here the loose of carbon dioxide, you can say attacking her the here thioester producing polyketide. You can see the ester, thioester, acetyl CoA. Acetyl CoA is used in a natural product synthesis. This is a coenzyme A esters, thioesters. So this is a, undergo this type of intermediate into the arsenic and 6-methylsalicylic acids. And this type of the ester condensation also used in natural product synthesis, malvanics, HMG-CoA pathway, natural product synthesis, Claisen sticker enzyme thiolase in retain produced by enzyme. Second step is aldol condensation. Number of natural product terpenes, polyketides, one can synthesize this way. Please watch the full video on biosynthesis in which I explain the Claisen ester condensation of thioesters. Please watch that tutorial if you are interested in thioester condensation, biosynthesis of natural products. So this is a ester condensation topics. Okay, please like and subscribe my videos. Thank you very much.